Hey Math 1, this is lesson 5.7 part 2. We were talking about special cases of writing linear equations given 2 points. They pretty much turned out to be vertical and horizontal lines when either the x coordinates were the same or the y coordinates were the same. To kind of wrap up this whole special cases assignment, I was going to show you what to do if you see decimals in the coordinates or if you see fractions in the coordinates. So, first example is you've got negative 6, 2.5, and 1.55. Now, the good thing about this is you're still using the y equals mx plus b model to write these equations. Let me find a marker that's stronger. Here. So there's 3 steps, right? Step 1. Find m, which we know is the formula y2 minus y1 over x2 minus x1. Assuming that this is x1, x2, y1, y2. Okay. Step number 2 is we pick a point. So you're picking an xy, and you've got your slope, right? And we're plugging those values into y equals mx plus b. Yeah, and then step 3 is just writing your equation at the end. So I'm just going to kind of leave that blank for now. Yeah? So here it is. y2 is 5. y1 is 2.5. x2 is 1.5. x1 is negative 6. So I guess here's the deal. You just got to straight up know how to subtract decimals. Okay? And in this particular case, I'm hoping you guys can do those calculations in your head. 2.5 is exactly half of 5. So 5 minus 2.5 is 2.5. Okay? On the bottom, a minus negative yields a positive value, so it's really just 1.5 plus 6. And there you can just say, what's 1 plus 6? It's 7. There's 0.5 extra. 7.5. Now, I don't think it's helpful to put decimals for the slope most of the time. So what we're going to do here is we're going to say you can multiply the top and bottom of this fraction by 10, or in other words, move the decimal place over one spot to create 25 over 75. Now, for a lot of people, that makes it a lot easier to see what the actual reducing fraction of that is. 25, 50, 75. So you can actually divide the top by 25 and the bottom by 25 and get 1/3. So m turns out to be 1/3. All right, step 1 complete. Now the question is, which of these coordinates seems to be the more convenient one to work with? Well, I'd say most students would pick the one that has a 1.5 and a 5 because they're both positives and they seem to be smaller numbers. So I'll just go with that as well. 1.5 for x, 5 for y, and then m is 1/3. So doing that plug-in, 5 goes in place of the y. In fact, let me show you guys in a different way. Y literally gets replaced with 5. M gets replaced with 1/3. X gets replaced with 1.5, and we're assuming multiplication's happening between the two, and then there's plus b. Okay? Now, 1.5 is the same as the fraction 3 over 2. And the way you guys can confirm that is 1.5 is equal to 1.5. And then if you convert that mixed number into a fraction, you take 1 times the denominator, whole number times the denominator, you get 2, and then add the numerator, and then still keep it over 2. So it's 3/2. So I'm going to rewrite that as 1/3 times 1.5 becomes 3/2. Good. I'm way more comfortable multiplying 3/2 times 1/3 than I am multiplying a decimal times 1/3. So now what we do is cross cancellation when you multiply two fractions. 3 divided by 3 is 1 over 1. So now you get 1 times 1 over 1 times 2. It's a half. All right, to close this thing out, we're going to subtract a half from both sides. The halves are gone, so b equals, well, take half away from 5. You're down to 4.5. Okay, so we got m equals 1/3, b equals 4.5. If we're using the format y equals mx plus b, then it's y equals 1/3 x plus 4.5 as my b. All right. So the decimal example, interestingly, turned out to be nothing but fractions at the end. And our second example, what happens when we have to deal with a fraction frenzy? Well, I'm going to label like I normally do. And I'm going to keep in mind that y equals mx plus b is the format that we're working with. Step 1 is going to be, well, using that formula, y2 minus y1 over x2 minus x1. Now this is going to be incredibly clunky, just like that. Because we've got a fraction that's going to have fractions inside of that fraction. Yikes. So I just want to plug in at first, okay? Maybe this isn't as bad as we think. y2 is 2/3, okay? y1 is negative 5 over 6. x2 is 2/5. x1 is 1. Okay, so now a minus minus becomes a plus. We got a couple options here. What I'm going to do is just find a common denominator for the tops and find a common denominator for the bottoms. So the common denominator on top would be 3 and 6 both divide into 6. So I can take 3 times 2, 2 times 2. You get 4 over 6 plus 5 over 6. So there is the numerator of my fraction. On the bottom, you got a 5 and a 1. So getting 5 to be the number that they both divide into is a pretty good idea. So 2/5 minus 5/5. All right. So it looks like just the finding of the slope is going to be a lot of work, but we can take it one step at a time. 4 over 6 plus 5 over 6 is 9 over 6. And then divided by 2 over 5 minus 5 over 5, that's going to be negative 3 over 5. Now I'm going to do two things at once on this next step. First thing is I'm going to rewrite it horizontally. So I'm going to take this piece of the fraction right here, and I'm going to say that means divide. So I'm going to say it's 9 over 6 divided by negative 3 over 5. I'm also going to reduce this fraction. 9 over 6 reduces to 3 over 2. Because you can divide 3 into 9 and 3 into 6. All right. This is good review, by the way, for how do we deal with division of fractions. Yeah, you keep the first, you change that to multiplication, you flip the second. Keep, change, flip. Flip the second and multiply. So 3 over 2 times 5 over negative 3. We've got cross cancellation. 1 over negative 1. So it becomes 5 over negative 2. Wow. Or negative 5/2. So it took a lot to just do step 1. M is equal to negative 5/2. Okay, number 2. This is where we pick one of these coordinates and try to move our way through the problem. So, what would be the one that makes the most sense to us, given the fact that our slope is negative 5 over 2, and that is going to be multiplied by the x? What would you rather multiply negative 5 over 2 by? 2/5, which is pretty much its reciprocal, or 1? Well, here's the thing. It's kind of hard to go wrong in this situation because multiplying by 1 is super simple. But multiply by your flip, you're going to get cross cancellation there. So here's what I'm going to do. It might be a bit controversial, but just try to deal with it. I'm going to make a bold move and say I'm going to pick 2/5, 2/3. And you guys are probably thinking like, what are you doing? Those are the ones with the 2 fractions. But watch this. Y gets replaced with 2/3. M gets replaced with negative 5/2. X gets replaced with 2/5. Wait a second. I'm sorry. Ugh. X gets replaced with 2/5. The 2's cross cancel. The 5's cross cancel. So 2/3 is equal to negative 1 plus b. And then all you do is add 1 to both sides. So I would posit that this is probably the more convenient ordered pair to plug in. Because 1 plus 2/3 is just 1 and 2/3. Anyway, you don't have to use this point, but if you do, that's how you work with it. So step 3 is make sure you actually rewrite the equation. Y equals, my m is negative 5/2, x, my b is 1 and 2/3, and I'm done. So, if you guys are like, hey, fractions are hard, you're not wrong. This is supposed to be a little bit challenging for you. So just, muster up the gumption to go through this homework assignment. The special cases will be really not time-consuming at all. You'll just look at it and say 20 seconds later, maybe 20 seconds later, x equals 5 or y equals 7. Those are pretty simple ones. These, they may take some time. Be patient with it. All right. Thank you for watching. That concludes 5.7.